Let's go to the YouTube stream up. It's always bad when I'm listening to music before I start the stream, because I like turn up the volume, but then I forget to turn it back down before I actually start stream. Okay, I think we're all good. I don't know what I'm gonna do. What should I do? I'm gonna maybe, oh, I wait to see if there's a question. Maybe we'll do E&M stuff. Oh yeah, thank you, Spetri. Yeah, I'm still trying to figure out like what my opinion on it is. I think I like the base game more than the DLC. The DLC was cool in its own way. Overall, though, it's like super good game and I really enjoyed it. And you know, I should have known that because the Spetri Certification Corp never misses. Yeah, I did it on like Wednesday or something, I think, last week. Talos, thank you so much for the 7 months. Holy crap. Is that another new emote? The holographic one? Your emotes are so good. And like, they're just getting better. But yeah, either way, thank you so much. I really appreciate that. So he doesn't have time to see the jump scares. Yeah. Oh my god, dude, that whole section was like so scary because like in the other part of the map where you can see them like walking through the forest, they have their lights turned on and they're really easy to see. But in that house, they are like some stealthy boys. Long time in Smiley terrifying. It's already yeah. It really is a long time. I've just been thinking about like how long I've been streaming. Like it's been a year and a half for me, I think. And it doesn't feel like it. Like it's just been so much fun that it's just like flying by. You've been streaming for over a year now, right? Or I feel like you started maybe like just a little bit after me, but you already hit your like 1 year mark, right? Killing it? I'm trying anyway. Over the weekend I did get to start reading through chapter 3 of this book. I remember it being pretty freaking difficult to understand. Can't stream for a little more than a year now. But, oh, okay. Well, that's awesome. That'll be hype. That's just a month plus a little bit. Your problem with the last puzzle of the DLC because you found 2 glitches by accident. So I was trying. Oh, really? I don't remember running into any bugs with it. I don't remember what the solution was now, but I remember I got stuck on figuring out how to. Oh yeah, I remember what the solution was now on how to get across that one bridge with the light shining on it. Which, like, how you deal with that? It's kind of crazy. I'm debating if I want to like start reading again from the beginning here. Yeah, I don't know. Hey, Scorpra, how's it going? The fact that you can live in the simulation forever. Oh yeah. The only cost is, having to die in real life. Um, hmm. Nah, I just want to go like I think I left off on going through on like I would start on 3.4, but let's just start from 3.3. Hey Navia. Yeah, just in the downtime stream right now, I'm reading through some physics. In Subajit, it is 1:17 in the afternoon for me. From terms of the potential function phi, for if phi can be found, we can get a 1's e from it. What was the problem again? "1:47 a.m. here? Why aren't you sleeping?" Exact mathematical solution of this case cannot be obtained in a straightforward way. Construct from an approximate solution. Observe it's not uniform over either of the conductors. So now total charge 0 is a negative charge surface empty in the region that faces the other sphere, and a positive, right? Okay. See, the problem that we're solving here is what the field looks like for an arbitrary arrangement of conductors and I think insulators. Everywhere outside the conductors, phi has to satisfy the partial differential equation we met in section 2.12, Laplace's equation. Hmm. Oh, I streamed yesterday evening, Joseph. Hey, Michael. It's electricity and magnetism. Laplace's equation. That good stuff. Don't you have a game to work on right now? Shouldn't you be like coding? Hey, Rubit. They're not nearly enough math streams on Twitch. I agree. Welcome in. And how many math streams are you aware of? Because if you want more, I can definitely send you a bunch of names. If it makes you feel any better, Joseph, I just lost my watch streak for a Daisy streamer I like, so uh we're in the same boat there. Yeah, so everyone in that list does math help in some form. So there's like a spectrum where some do only ever do math streams, some like sometimes play games, so sometimes do math, or they'll just only play games and switch over to math if someone asks a question. So there's like a little bit of a spectrum with people on that list, but they all like math and help people out with math. And there's even like a few more who'll stream in like the math category if you just keep an eye on it on Twitch. But these are the ones I can like recommend the highest. You know, actually like do like math help rather than like it's like a study with me type stream. And the 1080p 60 seems better, but the 360p 30 seems worse. Interesting. Okay, that's good to know. Would you normally watch in 360p? Hey, $10. How's it going? Gonna roll out sling watch streaks. So does not everyone have that? Because like for me, it just kind of started happening one day. I wonder if it's like a setting or I assume it's like a maybe it's still in beta or something. I don't know. Start watching 1080p but 160p when lurking. Oh, okay. Yeah, I've read a little less than half of chapter 3 so far. It's pretty dense. I think it's a smaller number of pages than the previous 2 chapters, but it feels like it's gotten denser for it. Alternative plot streaks similarly have the like meter that shows you a streak. Oh, that's annoying that it's not the same for everyone. Like not everyone has the option to like share it. I think you can only like share it at like certain milestones or something. Wait, 160p and 40p are gone? Huh. Yeah, I don't know how Twitch is going to do that because it's something that Twitch, like, the thing that OBS just updated for, apparently OBS scans your hardware and sends what your specs are to Twitch, and Twitch has some algorithm that figures out what the best load to put on your computer is to have your computer do the transcoding rather than their servers. And so I don't know if that, yeah, I guess I don't know exactly what that's going to mean for the end result. Love the Gojira post in the back. Oh, hell yeah. Gojira's awesome. 14 points in the show. Yeah, I think you can only like display the message in chat at certain milestones, but I don't actually know. I hardly ever even tried to share the one watch streak that I cared about. Actually, I should look. I bet I would have a watch streak in a bunch of like the mass streamers channels if I actually like checked it. Close by conducting surface, I'm going to say it's conductor potential, ignore anything outside it. So you have a boundary value problem, which is a value function. So boundary specifies the entire boundary. Yeah, like this terminology of boundary value problem. Does it not come up in differential equations? I actually want to Google that. I remember thinking that when I first read that. Oops. And I was like, oh, that sounds like a differential equations term. Yeah, okay. Don't scroll past this 1 minute read. Sorry, Wikipedia. I don't take orders from green boxes. Okay, this is another thing that I wish my like math classes talked about. It's called a boundary value problem because of these applications on physics. It's in the source manual. That's true. Oh my god. The only true source are random ass websites that no one knows anything about, but they agree with your already existing opinion. Wikipedia knows nothing. But I'm adding this onto the list of like, I've never taught like a vector field is called conservative because, like, I think with gravity too, in an electromagnetic field is conservative. Random sites not updated in 10 plus years are most optimal. I mean, that's actually true. Like Craigslist. That thing has not changed a bit, I don't think. I mean, like, this statement, I can just go with it, but I don't see... I don't understand what problem this is pointing out quite yet. Because the mathematical problem is a slightly different aspect. The only good source is a man named Bob, short for Robert. He's been an adjunct professor for 20 years, going on 60, the 40th year in a row. Ugh. Is that a reference to something, or are you just being like really specific with like a college professor? Just seems right. I mean, I would trust Bob. It's fair. No solution, more than one solution. And so I assume this question is like, does the partial differential equation, how many solutions does that thing have? Because like, whenever I hear this problem of like, how many solutions do you have, I think of like a matrix in linear algebra, which maybe there's probably, it's almost definitely a connection there too, I guess, but I assume talking more directly about the PD up there. Potential of each conductor phi sub k is specified together with the requirement phi sub b approach 0 at infinite distance. Connect them close to the system. Wait, you've been going on 60 for the 40th year in a row. Either you're 100 years old, I didn't even put that together, or you've been saying that you're going on 60 since before you were 60. Whichever way, that's kind of funny. Whose boundary value promise no more than one solution? Hey, Amar Kumar. What is linear algebra, please? I guess briefly. So I've only taken a single like linear algebra class, so I'm probably not the best person to give like that kind of high level answer. Hey Reaper, that's completely fair. I appreciate you popping in anyway, though. But yeah, no, I definitely don't want to force math on someone who doesn't want to talk about it. Common sense and quick wit, you're all for that? Fair enough. But yeah, Amar, I would say that linear algebra, at least as far as I've learned, is you basically have to do a bunch of things with matrices, and a matrix is, let me just show on the board. I probably have seen before is like a system of equations. If you have 2x plus 3y equals 5 and minus 4x plus 2y equals 8, like a system of equations like this, you've probably been taught some sort of way to solve this for x and y. What linear algebra does is it says you can make the same thing into a matrix equation, and it would look like this. 2, 3, minus 4, 2. I took all the coefficients from this side of the equal sign. I'm taking the x and y that we want to solve for and putting them in a separate matrix, or in this instance, you might call it a vector too. And then we have the answer column right here. And this is called like the matrix form of this system of equations. And to make it easier to solve, we sometimes write in what's called an augmented matrix: 2, 3, minus 4, 2, 5, 8. And from here, you have like a bunch of there's many ways to solve this system of equations here. One of them is putting into this augmented matrix form and doing what we call row operations, which I won't get into too deep into now. You could also use an inverse matrix and other things like that. The idea is that you can take this simple case and kind of generalize the technique to much bigger systems of equations, and you can figure out more easily when this thing has one solution, no solution, or infinitely many solutions, and what those would look like. So like this 2 equations, 2 unknowns is easy enough to solve like just by hand, doing things manually. But if you had 50 equations and 50 unknowns, you definitely want some linear algebra techniques to deal with something like that massive. So that's kind of like linear algebra as I know it. But I think if you study it deeper, or someone who has studied it deeper than I have, would probably give you a much different answer, because linear algebra goes a lot deeper than what I said just there. So that's kind of like my caveat. But if you're just like about to take a linear algebra class for the first time, that's like one of the concepts you probably learn first. The hourglass dog. Okay, let's see what this is. What? Okay. Its legs are so tiny. I guess I can draw this. There he is. Oh, I don't know, Reaper. It works fine for me. How are we gonna draw? If I don't have a yellow marker, so we're gonna have to make some what's the word? Artistic interpretations or something. We can maybe we'll just make it red, like Clifford. Hey, Devar, Devarfkek? I'm probably saying that wrong. So you want to write myself about percent. I think you're the right guy. Yeah, like, are you asking, like, how do you work with percents? Or if you have a question, I guess I can probably help you out. If just maybe, like, give me an example of a question that you're not sure about or something like that. In the meantime, I'm going to work on this drawing for Talix. The hourglass dog. Sounds like something from a video game. Okay, let's start with the ear. Goes pretty quickly into a snout. Got a little bit of a belly. Little leg. Another little leg. Another front leg. It's like an udder right now, but you know, it's all good. Does it have a tail? No tail, I guess. Okay. I wanted to know how to get percent out of numbers and numbers out of percent. Yeah, sure. I can try and give you like a little like general advice on how to think about percents and deal with problems including them. Let me just do this little drawing quickly here, and then we can talk about percents. Little eye peeking up over here. Nose. Then a tongue. Tongue looks kind of orange, so we'll use orange. Okay, I mean, that's not the worst thing in the world, right? Okay. Nice drawing skills, you're the second Da Vinci. Thank you, Dvorskek. I really pride myself on my flawless drawing skills. I'm glad that you have the refined taste to appreciate them. Okay, so if you're this is the way that I was taught to take percent, and it's kind of like really stuck with me because at least for me, this line of thinking works pretty well. So whenever you have to take a percent, try to translate it into this sentence. If we want to say 20 is what percent of 100? And you can translate this sentence directly into a math equation if you take the 20 and just keep it as a 20. The is multiplication. What percent is the thing we want to solve for? So we'll call it P. And of means equal, and 100 is just 100. Now we solve this for P, and that's our answer. Wait, did I get that reversed? Sorry, I got that reversed. Sorry, it's been a minute since I've... It's been a miss of actually I had to do. Sorry, is equal. Of is times. There we go, and that'll get us the right answer. So you have the equation 20 equals p times 100. Divide each side by 100. You get 20 divided by 100 equals p. And I happen to know that this is 0.2, but you can plug it into a calculator if you're not sure. And so that's 0.2 as a decimal. If you want to convert a decimal to a percent, you move the decimal to the left twice. And you fill it in with a 0. So it's actually 20%. And the neat thing about this technique is that it doesn't have to just solve for a percent. You can have like the what be any one of these like 3 things here. So you could also set up the sentence, what is 50% of 30? And do the exact same translation. What is what we were solving for? I'll call it x. Is equal 50%. We convert it to a decimal, so 0.5. Move it to the left twice. Of is times. Oh, I shouldn't use x. I'll use n, I guess, because I'm using that type of multiplication symbol. But all it says is the number you want is equal to 0.5 times 30, and so the number you want is 15, half of 30. So that's how if I ever have to do percents and I feel like I'm getting confused, I set up a sentence like that. Oh God, no, Joseph, that one's there's way too many things to draw on that. Hey, Stooky. So yeah, dwarf. So sorry about the little like flub there, but is this something that like might help you, or does that like make it clear? Just think of the think of it like the identifies as a whole, so you can have x is what percent of y, or what percent of y is x. Fair enough. Toji, welcome back. You're doing functional analysis. Oh, nice. Okay, so yeah, let's take that sentence you just said, and translate it to as an equation. What is 24% of 398? Yeah. So the what, we'll make it any variable we want. I'll just say n again. Is our equal. 24% we convert into a decimal to get 0.24. Of is times. 398 is 398. So like just said, all we end up doing here is 0.24 times 398, which that is not mental math for me. Actually, I feel like that's probably going to be a clean number, actually. Let's see, though. So you'd say 95.52 is 24% of 398. Probably hard to read on the stream. Less than 100? Depends on your purposes, I guess. You get it? Awesome. No worries. Percents, they can definitely get really tricky. Oh, and thank you for the follow. If you're interested in more math streams, actually, I'll just link them. There's a whole list of people who do math help. So if I'm ever not on and you have another question, I think anyone in that list could answered that or a question like that in a very like, you know, they'd have a very good explanation, and they'd be able to like help you out with it. Hey, Anders, how are you? Oh, true. Thanks, Stooky. There's also the Discord where you can try and like I I if I'm not on, you can ask a question in there, and I do try to like get back to people in a timely manner, but I'm not available like 24/7. Often someone is around who will answer the question if not me. So let's erase the board. Okay. You know, I'm kind of curious because I wait up. What does the just the Wikipedia page for linear algebra even say? Ethan already finished his new setup. I think he's getting close. Maybe he was streaming last night, and I remember looking at the checklist. I think he's nearly there, but not quite there. I don't remember what exactly is left for him to do though. What's up with the Scooby? Oh, it's apparently the hourglass dog. It's what Talos had me draw. The head pat. I love your emotes, Eldritch. You always have good ones. The 9 chapters on the mathematical art? I never heard of that book. That's a really cool name for a book, though. It's a famous oldie? Yeah, my history math class skipped right over this. It mostly focused on Western mathematicians. So we talked a little about, I'm going to butcher his name, but Ramanujan. And whatever Chinese mathematician got a really good approximation for pi, and that's the only like non-Western math that I can remember learning about. Some kind of dog in an hourglass. Hourglass dog. What did it deal with? The approach to mathematics that centers on finding the most general methods of solving problems, in contrast with deducing propositions from a set of axioms. Okay. Is there an example of a problem? So I remember reading the types of problems that like the ancient Babylonians were doing, and it's actually like kind of cool. They use negative numbers. Ooh. Subtraction is divide by the same name, benefit by different names? Division is subtraction, benefit is addition. Huh. No entry means there's no counterparty. Whatever that means. Equation and division are not recorded. Huh. How would you solve a system of equations without multiplication and division? Sorry, like I, I think history math is really like cool angle setting math, and it's easy for me to get like sucked into this, but maybe I shouldn't. um, Spend that much time on it. Okay, I just want to read like the table of contents, and then I'll put it down. So the areas of shapes makes sense. Oh, maybe this is the mathematician who got a. No, I think maybe there's a different mathematician who got even more digits. Major change of combines at different rates, unit pricing, rule 3 for some proportions. Oh, wait. What is the rule of 3? I've heard people like make reference to it, but I never like learned it for myself. Oh. Just rearranging the, like, okay, well, that's boring. Proportional distribution. Oh, okay. Reducing dimensions. Diameter or side of shape given as a volume or area. Division of fixed numbers, extraction of square and cube roots, diameter of sphere. Ooh, okay. Figuring for construction, volumes of solids. Equitable taxation. Okay. Excess and deficit. Linear problems and two unknowns. Oh, okay. Two-sided reference equations. Okay. Pythagorean theorem. Okay. Anyway. Maybe we'll go back to reading through the physics stuff. Settle down in some state, however, it is quite a different matter to prove. And the solution always exists, and we shall not attempt it. Prove the following theorem. Assuming that there is a solution, phi xyz for a given set of conductive potential phi sub k, the solution must be unique. Right. And so I don't know if I should care that much about the proof, but hey, person on YouTube, I don't know how to pronounce your name, but welcome in. And Alistair, hey, welcome in. I'm not going to prove too much. I read through it once and I feel like I half understood it, and I think I'm going to understand even less this time. Probably more reason to read it, but I'm lazy. quick corollary, in the space inside a hollow conductor of any shape whatsoever, if that space itself is empty of charge, the electric field is 0. Which is weird. I don't really do physics, so I like this right here. I'm studying some electricity magnetism just because I think it's interesting. I'm not particularly good at it though. So if you're like can ask for physics help, I can maybe do it if it's something that's fairly basic, but I've forgotten a lot of the physics that I've learned. Maybe outside the conductor. Just the gravitational field inside the shell of a hollow spherical mass is 0. So the problem here is to clarify. Yeah, sure, I can try and give you my opinion. If you want, type it out there in chat, or if it's easy, you can put it in my Discord. 5 seconds, a body covers a distance of 50 meters. Oh, okay. I'll paste this over to Twitch chat just so they can see it too. Counted 100 times, the correct answer will be 90. The correct answer is 110. And Alistair, my favorite math topic is systems of differential equations. Actually, I keep forgetting to use this command. Oh no. Wait, is StreamerBot... Oh, don't do this to me, StreamerBot. Curse the day I updated my OBS. No, it's for the better, I think. Well, give me 1 second. I need to fix this issue. Really? That's weird. Connect. Okay. Okay. There we go. Hopefully that doesn't happen again. Now let's actually think about the problem. In 5 seconds, a body covers a distance of 50 meters, and in 10 seconds, it covers 80 meters with uniform acceleration. What is the distance traveled in 15 seconds? Wait. Why is this not 50 plus 80 equals 130? Is there like a picture where like it's going at an angle or something? Wait, oh, in 15 seconds. No? The correct answer is apparently 110? I don't see how that's possible. How are you getting 90, I guess? Because I'm confused why you wouldn't just do 50 plus 80. How are you getting 90, Phil? That makes no sense to me. Okay. First 5 seconds, 50 meters. Second 5 seconds, 30 meters. Third 5 seconds. So, wait. Oh, wait, well... Anders, you're saying B? What? Tiny little changes due to the acceleration. Changes in motions take into account the initial velocity. They literally say the distance that you cover, though, and then they ask for distance traveled. I still don't know why it's not just that simple. Like, sure, it's accelerating, but we only care about the total distance that we're traveling, and they tell us that directly. Meters with uniform acceleration. They cover the distance of 50 meters. Second 5 seconds. So they give us 15 seconds worth of things to go off of. If they said maybe like in the first 10 seconds, I agree you'd have to carry the acceleration. Oh, wait. Is it 80 total meters? Hey, SPQ. So rather, it only did an extra 30 meters in the 10 seconds? Oh, maybe I misinterpreted this. Like, the first 5 seconds is part of the next 10 seconds. I think they mean the same thing, Anders. Okay, I think I see. It's like at time 5, it's at position 50, and at time 10, it's now at position 80. In which case, yeah, we absolutely need to care about the uniform acceleration. And we can work that out, can't we? It's a trick question. The answer is 130. Apparently, it's supposed to be 110 SPQ. Well, like Lars on YouTube chat is saying that it's definitely 90, and that we're originally asking is saying it should be 90. And I think I see what you're saying, Lars, where it does seem like it's decelerating, where it covers 50 meters in the first 5 seconds, but then the next 5 seconds, it only covers an extra 30 meters. Huh. Okay. So it's like you're losing 20 velocity each time. Stuki likes 90 as well. Problem is underspecified as PQ says. Differentiating kinetic equations, I guess. Yeah, I'm trying to figure out how, like, I would love to, like, I think I'm on board with it maybe being, or like probably being 90, and there's maybe a mistake in the answer key. I'd love to be able to, if we can get to 90 like a second way, that would make me feel even better about it though. It's saying S equals ut plus 1/2 at squared. Okay. Except, we don't really know our velocity, right? We get like the average velocity from 5 to 10. Yeah, Lars, but then like, that. Okay, yeah, I'm curious to see how that works if we do that. S is equal, I'm gonna say V sub 0 and half at squared. If we plug in the 2 points, we can get 2 equations and 2 unknowns, which I'm just kind of curious to see if this would work out to be 90 as well. So we have 50 and 5. And we have 80 and 10. And so that's 2 equations, 2 unknowns. Let's see what happens if we solve it. I guess let's multiply the top one through by 2. Subtract them. Minus 25a. So we're getting a is minus 4 over 5, which, is that reasonable? Probably. I guess we could get V naught as well. 25 over 2 times 4 minus 4 over 5. 5 times 2 is 10. $12 is V naught. And so if we want to figure out S at 15, we would do that. And I'm going to let Wolfram Alpha do that. Oh, so you did the same thing. A is 2.5, U is 12. Okay. So we're getting the same thing. I'm inclined to say there's probably an error in the answer key then, because I think we're about to get the same answer here. Wait, what? Oh, I didn't erase the old problem. Oops. 90. Why not solve it by hand? Because I'm lazy. As soon as even delete the old problem from Wolfram. All right, yeah, I don't know what to tell you other than there's either something going on with the problem that I'm not aware of, or there's an error in the answer key. Factor out of 15. You still have to do fraction math. That's why I didn't want to do it by hand. If that 1/2 wasn't there, then yeah, sure, but... Oh wait, it does cancel. Never mind. Well, I already plugged... I already put in the calculator, so oh well. Lars, you mean what I was studying like right before that problem? I have been studying electricity magnetism just kind of for fun. If you mean in general, what am I studying? I graduated with a bachelor's in applied math like maybe 6 years ago. And I'm not currently a student. Some constant velocity. That's what I was getting stuck on too, Anders, I think. Yeah, Lars, I just think that the math and physics is really interesting, so I've been reading out of this textbook and doing an actual like reading group on Saturdays. Day 73 of your latest journey with Dog. Yeah. What's the next like big number after 69 for the streak? I mean, I guess 100 is like the next big one, and then after that, like 169, I guess. 6969, hell yeah, P-ish. Work friends before 6969, that's true. Man, I almost don't feel like looking at this because it's just like so freaking dense. There's a good amount of threads open on the math Discord. Let's see if we can find something. This just feels a little bit too heavy for me right now. Oh, look up. Let me look at what Beastboss just put in chat there. 4 persons independently solve a certain problem correctly with probabilities 1/2, 3/4, 1/4, and 1/8. The probability that the problem is solved correctly by at least one of them. Ooh. That's going to be a binomial distribution problem. Binomial probability. Oh wait, but no, it's how would that work? So my first inclination is just add them all together, but that gives you that's definitely wrong. Hey, it's G1. Glad to see it. It's almost like a binomial distribution, but I guess it's not quite. It seems like there's a lot of combinations you have to add here. You'd have to do it. I wonder if there's a way to make it more compact. I think you'd have to account for every scenario of at least one of them getting it right, which it's going to end up being a lot of math, or like a lot of arithmetic. I don't know if there's a way to compress it, but I think you would have to. You would have like probably 4 factorial different scenarios to worry about, or maybe 2 to the 4. I think probably 16 different things to add up. 1/2, 3/4, 1/4, 1/8. So like you have the scenario where they all get it right, which is 1/2 times 3/4 times 1/4 times 1/8. They're all right, but you have to add all the other possibilities, which is say like the last person got it wrong, which seems like I think I'm trying to figure out if there's an easier way, but like this is gonna be a lot of work to get all the scenarios. Like there's just a lot of them. And then you'd have to like, repeat this process to get every single combination of right and wrong people with at least one person right. Oh, wait. Sorry, I figured it out. That's the long way of doing this. What you do is you figure out the probability of them all 4 being wrong, and you do 1 minus that. That's the shortcut. Sorry, I'm not the best with probabilities. Is equal to 1 minus probability of none right. And there's only one scenario where none of them are right. So you don't have to count 16 different things. Yeah, you're right, it's PQ. Stephen Armstrong's memes. Yeah, what's the problem? So I would say we do 1 minus the probability of each of them being wrong multiplied. So 1 minus 1/2 is 1/2. 1 minus 3/4 is 1/4. 1 minus 1/4 is 3/4. 1 minus 1/8 is 7/8. So Biswas, I'd say your answer is 235 over 256, or 91, or like 92% basically. Let me know if you have any questions. No worries. And Stephen, the first 3 terms of geometric sequence. Oh God, what is that? British math? How is that a geometric sequence? What's being multiplied each time? Um, 17 to 18-year-olds? Oh God. I guess if we want to figure out what's being multiplied each time, we divide 2 consecutive terms? Oh, let me get that last part added on. Hmm. If you want, you can put it in my Discord if you have a Discord. In the meantime, I'm going to start thinking about this, though. I guess there's a thing that I said where we divide, if I take the first 2 terms and divide them, that should be our R, right? Yeah, Jed. B over A. Oh, those dang A levels. Okay. Your final boss. Yeah. I've seen some A-level problems before, and they're never easy. Hey, Aditya. I have a bachelor's in applied math, and I've worked in a tutoring center for a little under a year. I've also informally tutored a lot of friends. Oh, I think maybe the ones I looked at are further math. No, I'm saying that I think in the past I've looked at further math problems. And indeed, yeah, isn't the integral of x to the x? Which I don't know if that has a clean integral. But I'm looking at this problem right now anyway. Amisha, I'm not sure where that's coming from. Sine of theta is a half. I was just wondering, like, how do we? I don't know, like, what they want us to show in part A. Like, we can do part B to solve this equation up here. I don't know what they mean, like. Like, we have to arrive to this equation somehow, is how I'm interpreting this. I guess let's try the ratios. AB equals B over C. Or A over B equals B over C. Five plus 2 sine theta. Five plus 2 sine theta over... So this is from it being a geometric series, I guess. We know that this proportion should be true. And if we cross multiply stuff... Oh, tangent is sine over cosine. Okay, so that's why this is a good idea. Two sine theta squared, and so the cosine thetas are going to cancel, and we get 12 times 6 is 72. Sine theta equals 25 plus 20 sine theta plus 4 sine theta, or squared. Subtract the 72 over, you get 0 equals 25 minus 52 sine theta plus 4. Oh, wow. Okay, that wasn't as bad as I thought it'd be. Okay. So all we do for part A is we set up, because it's a geometric series, the thing that's being multiplied by each term is the same. So if you take the first term divided by the second term, that proportion is the same as the second term divided by the third term because of how a geometric series works. Actually, I guess it's a sequence. They call it a series, though. It's not that important. Hey, Storm Shadow. I don't know what you mean with the decimal calculation. Oh, Misha asked me to solve that? I'm focusing on this problem first. I'm not sure. I don't think you can probably solve this without completing the square. I think it's factorable. So if we want to factor this thing, there's a leading quotient that's not 1, so it's a little bit harder, but we can definitely set up something like something sine theta plus or minus 5 times something sine theta plus or minus 5, and now I'm going to guess and check to fill in the rest. It's either a 1 and a 4 or a 2 and a 2. Or that could be a 25 and a 1, I guess. I don't think it's going to be that. Oh, it actually, no, it probably is that. They should both be minuses. A 25, a 1. We want a 2 times a 25 and a 2 times a 1. So I think these are both 2s. And now if we reverse engineer it, 4 sine squared theta minus 50 sine theta minus 2 sine theta plus 25. Hey, I got it. Okay. And so we either, from this equation, we get 2 sine theta minus 1 equals 0. And from this equation, we get 2 sine theta minus 25 equals 0. This one, I think we get no solution for. Because sine theta is never equal to 25 over 2. From this one, though, we get sine theta is 1/2. We can definitely find... There's 2 places in the unit circle where this happens, but they give us a hint for which one to choose. Hey, JT Wesky fan, welcome in. They say specifically that theta is an obtuse angle measured in radians. So on the unit circle, sine of theta equals 1/2 at pi over 3 and at 4 pi over 3? Is that what that angle is? I think it is. I want to look at the unit circle now, but it should be this angle right here, because this one is the obtuse one, whereas pi over 3 is acute. It's less than 90. Oh, shoot, you're right, Aditya. I'm picking the wrong part of the unit circle. Sorry, it's pi over 6. Or this angle over here, which I think is 5 pi over 6. And we still want the greater of the 2 angles. Let me verify that I'm... Remember my unit circle right. Yeah, 5 pi over 6. So I guess that's the answer for part B. And there was a part C to this as well, right? Sum to infinity of the series can be expressed in the form just take it off the screen. Husky fan, I need help with to add the runtimes of YouTube videos to the total runtime. I'm not sure what that means. If you can maybe give me an example of what you mean or something like that. Oh, I see what you mean. Oh, well, thank you for the kind words there, Aditya. Yeah, let me answer that, Wesky, quickly before. I'm still thinking about part C. I think we need to figure out, we need to use A over 1 minus R, but we need to figure out what R is, I guess. But before I do that, let me just quickly help you with the runtimes. I would take It's what Obi said and some of what Pachinko said, and what that means is I'm gonna take all of the minutes and add those 1 plus 3 plus 4 plus 7 to get 15. I'm gonna take all the seconds and add those. 47 plus 39 plus 46 plus 28 and 160. So we get 160 seconds. So it doesn't make sense to have 15 minutes and 160 seconds because there's only 60 seconds a minute. So we have to convert this 160. We need to take all the minutes out of it. So what we're going to do is we're going to take 160 and we're going to keep subtracting 60 until we get something that makes sense. So if we take out 160, if we take out a single 60, we get 100. That still doesn't make sense. So let's subtract 60 again. And then we get 40. So we subtracted 60 twice, which means that's 2 minutes. So we're going to take that 15 and add 2 on. And this 40 is going to be our seconds. So I'd say the final answer is 1740. That's kind of like the intuitive way I would say to do that. Basically, you add the minutes together, add all the seconds together, and then because your seconds are too high, you convert the extra seconds into minutes. That's another way to do it too, Jed, but I think it's a little bit harder for this purpose. So let me know if that makes sense. I should keep thinking about this problem though. So do we just know, if we know what theta is, can we just plug into the initial 3 terms that they give us here? That's my inclination. Oh, I guess let's take that problem off. So if theta is 5 pi over 6, what's 12 times cosine 5 pi over 6? Cosine is minus 3 root 3 over 2 there. Five plus 2 sine pi over 6. Five, we already said that's a half, so it's just 5 plus 1 equals 6. And okay. And then we have 6 tan theta. 6 tan 5 pi over 6. Tangent's going to be negative. We have y over x. Y is 1/2. So it's 1/2 over root 3 over 2. Which is equal to 6 times minus 1 over root 3, which is equal to minus 2 root 3? Yeah, so I think each time we're dividing by negative root 3. Hey, Zamatrix. I can look at that in a minute. If x equals x plus 2 with a minus sign, are there any complex? I don't know about that, Aditya. I'm going to keep working on this problem for now, though. I think from this we can claim that, well, what I want to do here is use the formula for the infinite sum of a geometric series, s equals a over 1 minus r. A is the first term, r is the proportion you're multiplying by each time. And I think from this, we're dividing by root 3 each time, and the sign is alternating, so it's negative 1 over root 3. And a is just whatever this thing is here. Minus 6 root 3. So let's plug these two numbers into the formula and hope that we get the correct answer. Minus 6 root 3 over 1 minus negative 1 over root 3. That's annoying, to say the least. Really? Okay, we're gonna have to do some rationalization here, and I'm not happy about it. 1 plus root 3 over 3. I'm going to multiply top and bottom by 3 over 3 to get rid of that fraction in the bottom. Minus 18 root 3 over 3 plus root 3. And now I want to get rid of the skirt from the bottom, so let's rationalize. Multiply top and bottom by 3 minus root 3. So we get 18 root 3 times 3 is minus 18 times 3. 54? Plus 18 times 3 is 54. I hope. 3 times 3 is 9, minus 3. I'm technically correct, thank you. So this is 6, we divide each of these by 6. Please tell me 6 does go into that, 9 times. So we get 9 root 3 plus 9. And factor the 9 out to get 9 times root 3 plus 1. So k equals 9. Oh no, there's a minus sign. Ah. I dropped that. That was my issue. There we go. Now I'm right. Let me know if that makes sense, Stephen. Okay, so there's people put a few problems in the YouTube chat. Let me try and catch up with it. So I think the earliest one I remember is Amisha. Cosine, I assume squared of 73 degrees plus cosine squared 47 degrees plus cosine 73 degrees times cosine 47. If this supposed to be an exact value, that looks a little difficult to solve. Computer considered a glorified calculator? I guess so, yeah. You're still not really actually convinced. You're still not convinced actually has to find k. Oh, well, not my problem, Jed. Yeah, they're not asking you to find k, I guess, SPQ. You're right. They're saying someone has to find k. Yeah, I haven't seen Amisha type in a minute. So Matrix, if you're still here, I can attempt that. I don't know what to do with that series, I guess, the more I look at it, though. From 100 to infinity of n over n to the power of ln n. Is that just to prove convergence or actually finding the value of the sum? And then Aditya, I feel like there's something missing from that equation. I'm just trying to figure out who's still here in the YouTube chat. Jed, I guess I can't, like, I'm not supposed to actually show the YouTube chat on Twitch is the issue, so. I wish I could, but. And okay, so Paracrystal, I guess that means you, if you're still here, hopefully. I can probably figure this out. Let's see. JT, yeah. I'd say Floating Evade is my favorite game. Hey, GapQ. Series of the first 10 terms series 13 over 5 plus 13 over 5 plus 13 over 5 plus 4. What? I don't know what the pattern is there. What's in that dot dot dot? It indeed. Oh, okay. It's a matrix. Sorry, I couldn't look harder at your problem. Yeah, Paracrystal. I don't know that this. I don't know this question is possible because we don't actually have a pattern here that we can reliably say it must be. JT, what's key fan? Yeah, I love Fallout. Okay, so yeah, Amisha, I guess Paracrystal, let me know if there's maybe a typo in that question or something. But Amisha, for your question with the cosines, are you allowed to plug it into a calculator? Or what, like, what are you trying to solve for? Oh wait, are those it's 90 minus 47, 73. That could solve the problem for us right there, potentially. No, I don't. No, it's not. What? Oh, sorry, my watch just talked to me. Paracrystal gave a correction. Amisha put their problem in chat first though, so I'm gonna work on Amisha's problem first though. Paracrystal, I'll come back to yours. Sorry, whenever I ask a question at once, which kind of is what just happened, I just have to prioritize. So I'm sorry that I can't get to everyone as soon as they ask the question, but I'm just one person here. So I like the suggestion that, who was it? In normal, I see your thing for proving the Euler's identity. I don't know that I can do that. I like what GatCube is saying with factoring it, at least for a start. I know about the Q command, Obi, and I want to make my own version that it's going to serve my needs a little bit better. And even then, even the bot isn't on YouTube, so. Which I guess it doesn't necessarily have to be if I just manage it myself, but. I want to be a little bit more than just a Q command. So this thing, it definitely factors. Oh, that has to be a 2 though. That doesn't factor perfectly. You could factor it like squared minus this thing. Why am I doing parentheses now, but nowhere else? but there's no 2 there, so it doesn't factor perfectly into that a plus b squared. Does that even help us? Sum to products might be nice for inside the parentheses here. And maybe even product to sum for the... Yeah, I want to try applying... this formula to the thing inside the parentheses and this formula to the thing outside the parentheses. And hoping for the best. How does the formula look? I already forgot. 2 cosine 73 plus 47 over 2, the average. 80 plus 40 is 120. 120 divided by 2 is 60. Oh, hey. That's a nice angle right there. And then you do that minus that over 2. What is that? 73 minus... I'm not doing that mentally. 26? I might have just done it mentally. 27? No, wait. 26, okay. And over 2 is 13. Right, thank you, Jed. Okay, so cosine of 13 isn't nice, but what can you do? Then the product to sum, cosine, the first angle minus the second angle, which says 26, times, nope, no, plus cosine of them added, which says 120. What did I just write? Over 2. Okay, we might be able to work something out with the 13 and the 26. Cosine of 60 degrees is 1/2. Forgot the cosine? Oh, yeah, you're right, Jed. What a mistake. Okay, cosine of 60, I believe is 1/2. No, yeah, it's 1/2, so it cancels the 2. So we just get cosine squared 13. Oh, that's gonna go nicely with a double angle, I bet. Cosine 26, cosine of 120 degrees. Negative 1/2? What do our double angles look like? Cosine squared is equal to 1 plus cosine 2 theta over 2. So on this, I'm going to do a, I guess it's called a half angle. It's going to be 1 plus cosine 26 over 2, that first thing. Then let's Split this up into two different things. The cosine's going away. That's a good sign. Good cosine, one might say. Yeah, the cosines cancel. We get 3/4. Let's check that in Wolfram. It's a lot cleaner than I thought, well, let me tell you. Bam! 3/4. Thank you, Ahmed. GapQ, great call on that initial step for factoring. And Jed for catching my mistakes. So yeah, Amisha, as long as you're willing to use these a little more vague sum to product and product to sum identities, it works out pretty nicely. It's definitely hard to spot that though. I was just hoping for the best for most of that. Thank you, $10. Okay, so Paracresol, if you're still here, and Misha doesn't ask anything, let me start looking at yours. Oh yeah, sure, Amisha. I didn't do the set problem. Oops, I'll do that in a second. Yes, because I didn't really do the job of explaining that. So, how I did this problem is, this looks like something that's factorable, but there's a slight problem where, if we looked at this and we factored it to just like a plus b squared, it actually isn't quite right, because cosine 73 degrees plus cosine 47 degrees squared, you would get cosine squared 73 plus 2 cosine 73 cosine 47 plus cosine squared 47. And this nearly matches our original problem, but there's no 2 here. Like, this mismatch was the issue. So what I did is, I subtracted off the extra, I basically, on this original equation, I did a plus cosine, 73 degrees, cosine 47 degrees, minus cosine 73. So I'm only technically adding 0. But combining these two into the 2 cosine 73, cosine 47 allowed me to do this factoring here. And then that minus part is still stuck onto the side there. So that's like, that was the first step that I did. Rubit, thank you for the follow. And once I had it in this form, I just looked for any identities that I could use that could potentially be helpful. So in this one, I did the product to sum identity, keeping the squared on the outside. And the product to sum identity is cosine theta plus cosine phi equals 2 cosine theta plus phi over 2 times cosine theta minus phi over 2. So that's how I went from this on the inside to that on the inside, just with that identity there. And on this term over here, I did kind of the opposite, formula product to sum, which is really just rearranging of that formula over there, I think. or a different version. Ligi, thank you for the follow. Welcome in. Nothing much with me. How about you? Ahmed, how do you remember all the trig identities? I remember the Pythagorean identities. All the rest, I don't remember them, to be honest. I have to look them up, unfortunately. There's a lot of them, and which one you use at what time is really hard to know. Trig problems are just tough. So part of sum cosine theta times cosine phi is cosine theta minus phi plus, I can just look at the work I did and figure it out, but I'm doing it like this, I guess. Plus cosine theta plus phi over 2. So those are the two identities that I used in going from the second step to the third step. And now here, I noticed that cosine 60 and cosine 120 are both unit circle values. So I just evaluated those. Cosine of 60 is a half, and 2 times a half is 1. Cosine of 120 is minus a half. So all I do is evaluate the easy angles and plug those in. So we end up with cosine squared of 13, a cosine 26 over 2, and a minus 1/2 over 2. And then I noticed that I noticed that 13 and 26, it's just, 13 times 2 is 26, and we have half angles and double angle identities that can help us out in these scenarios. So on this cosine squared, I applied a half angle, which is cosine squared theta equals 1 plus cosine 2 theta over 2. And that's how I got this 1 plus cosine 26 here from this step to this step. Over here, I just split up that over 2 to be just on the cosine and just on the 1/2. The tricky thing here is, remember, there's a minus on the outside, so it's minus 1/2 cosine 26, but then minus a negative 1/2 over 2, so it flips to plus there. I mentally split this thing up into 2 fractions as well. I didn't show that part, but that's 1/2 plus 1/2 cosine 26, and 1/2 cosine 26 minus 1/2 cosine 26 is 0. So all we get is 1/2 plus a fourth, which is 3/4. I hope that makes sense. Just Oligi, just learning analysis. Oh, nice. Oh, and Rubit is your brother. Cool. Hey, Phobos. Awesome, Misha. Glad to hear it. Yeah, I've heard that some people they don't memorize trig identities, they just use complex numbers to derive them again. I don't know the derivations, though. Yeah, Hala. Oh, yeah, horses. And so yeah, I do dual stream to YouTube and Twitch, so if you see me on Twitch talking to someone who's not there in chat, they're probably on YouTube, and vice versa if you're on YouTube and see me talking to someone on Twitch. The Twitch chat is displayed up there. I can't display the YouTube chat, though, because Twitch has stupid rules. Okay, so yeah, sorry that I didn't get to your question. Is that question still loaded up, Jed? From Paracrystal, show problem. Okay, cool. I wish I could make resizing that box a command, or something a little bit more automatic. But I don't think I can access that streamer bot. I can find a setting in OBS to resize it that dynamically either. Okay, so this is from Paracrystal. I don't know if you're still here, so sorry about the wait. This one's diverging, you're saying, Gap Q? Yeah, the terms are increasing, aren't they? Well, well, they're not asking about convergence or divergence, they're just asking for a finite sum. So that should be fine. Problem all the way across the top, slide chat down a bit. If it's above the whiteboard. But then wouldn't chat cover up the problem sometimes, depending on the length of the problem? Maybe not. This isn't what you're saying, right? Let me look up the formula for... Oh. What's being multiplied each time? I guess it's not geometric, is it? Oh wait, isn't there a formula? Sum of squares, yeah, gap Q. Here we go. Except we don't have something as clean as that. Well, like, how far down do I slide chat, though? The problem sometimes it's long enough to go behind my camera. They found a slightly different looking formula, gap Q. I wonder... This is the formula I was thinking of, but it doesn't actually help here directly, does it? We can actually... Oh, we can factor out a 1/5 squared. That's constant. The only summation that's actually happening is in the numerator. Yeah, Jed, I like doing that. So 8/5, 12/5. I want to see if I can force it to look like the sum of n cubed. That's kind of my goal right now. 16. Oh, and the 4 happens because it's 20/5. Okay. So I'm going to write that 4 squared as 20/5 squared. Okay, so... First thing I want to do is write this as sigma n equals 0, n equals 1. To 10? That is 10 things, right? From 1 to 10? Yeah, it should be. 4 times n/5 squared, right? No, we start... A 2 in front? Is that what we want? No. I guess we're starting from n equals 2 to 11? Because that would get us 8, then 12. And 2 to 11 is hopefully still 10 things. It should be. And this 4/5 squared can come out front. That's the answer, I think. That's the key realization here. And that's nearly in the form where we can use that formula that I just showed on screen. Yeah, I think if we want to turn this back, I guess we want to start from n equals 1. Should be n plus 1 squared? So does that make sense? We're going to get, when n equals 1, we get 2 squared. 2 times 4 is 8. When n equals 2, we get 3 squared. 3 times 4 is 12. Yeah, okay. And oh wait, no, it can't be, yeah, Jed, we have to do that. We have to start from, I saw the way the formula is given, we have to start. It has to be just n squared and it has to start from 1. And yeah, okay, that's what SPT was saying. Hey, Master Mantis. Over on YouTube. New here, so I have 2 questions. Did you learn calculus? Yes, I learned calculus. Where did I learn it from, and what is the best book? I learned it at first in high school from taking an AP class, and then I took it again in college or university. I have a bachelor's in applied math. The best book, I have a hard time giving book recommendations because I just don't really know them that well. I think like Stewart Calculus is the popular one. Looks like Gap has recommendation there too. I can give you, if you want to learn just like practical, like getting through calculus class, I do really like this website. It doesn't talk about the theories much, which is the reason why I like it, to be honest. I like the site for everything calculus, and there's a YouTube channel called Black Pen, Red Pen, who, like, you maybe wouldn't learn calculus from the ground up, but if you just want to, like watch some fun calculus videos as a break while still doing something, I think that's a good channel to watch. 4 plus 4 and on top. Oh, probably, yeah. So the formula for the sum of squares is 1, 6, n plus 1, 2, n plus 1. Okay. So applying this formula to this, get 16 over 25 times 1, 6 times 11 times 12 times 23. One 6 times 12 is 2. 2 times 11 is 22. 22 times 23. I feel like there should be a trick here. 22 times 23. I feel like it's going to be something obvious looking. Oh, yeah, that's going to come out to be clean. 506? Oh, okay, that's actually not that obvious looking. 506 minus 1 is 505. What was the original problem? 16 over 5. Oh, we need to bring a 5 in. We want it to be 16 over 5 times the numbers. And so 25 is 5 times 5. So 505 divided by 5 is 101. So m is 101, I'd say. No worries, Master Mantis. 22 squared plus 22. Oh, that was probably the key, yeah, gap Q. So yeah, I think Paracrosol's probably not here, but in case they check the VOD, it's here, I guess. Okay, fun problem. What's the difference between pure and applied? I don't get it. So I majored in applied math. The exact difference between pure and applied math probably depends on the university, to be honest. I would say kind of generally applied math focuses on, you know, like the name says, applications. So as part of my major, I learned about, we focus a lot on like differential equations and how that can be used to model real world scenarios. But applied math is basically just any type of math that has a more direct application to real world settings. Like how? Let me show you. So there's these Lotka-Volterra equations. It's a system of differential equations, and it's also called the predator-prey model because it turns out that these equations here can be used to model kind of like the push and pull of populations of predators and prey. So if you have a whole bunch of predators and very few prey, these equations can show how the predators are kind of slowly die off because they don't have enough food, and then as the predators die off, the prey starts to increase because they have fewer predators, and there gets to this kind of like equilibrium eventually. Or if you have some other like a bunch of prey and very few predators, it can model like from that starting point how it ends up, basically. There's also the SIR model. So Wikipedia can actually show. It's like the SIR model models the spread of diseases. S is the number of people who are susceptible to a disease. I is the number of people who are infected. And R is the number of people who are recovered. And so they have the graph of each of the three kind of things here where as the people who are susceptible, or sorry, as the number of infections increases, the number of susceptible people decreases because they're now infected rather than susceptible. And as people recover from their infection, the number of recoveries will kind of like take away from the number of infections. It's all kind of linked. So that's stuff that I was doing as part of my applied math major. That's a good question. I don't know enough about them to say whether they're derived or obtained experimentally. I imagine they're derived, and there's a bunch of constants that you would adjust to try and make it more closely fit a real situation. So like this beta, the gamma, you would find those experimentally for a specific situation. I feel like you're gonna have some weird limit question that I don't know corrupt, but in like a normal calculus class, I'm pretty good at those limits. Ahmed, my name on Twitch is the same, Don Does Math. And so I'd say that pure math, which I don't have much experience with, it can take a lot of forms. and I'm sure applied math could take more forms than just the kind that I learned. But pure math, I think of things like abstract algebra, which is the study of how you can make different types of math, basically. And the connections between our existing types of math, like real numbers, complex numbers, matrices, like what kind of parallels can we draw through all those different types of math. I'd say also like analysis is pure math, where you're taking things that we're pretty sure we already know about math and making them formal, I would say. Like it's kind of like the proofs behind like calculus is where you would start with analysis. Relating to your sine of z equals z problem. I'm not optimistic I'd be able to do that corrupt. Oh, I'm sorry, Dr. Drunkenstein. I saw your thing and then I skipped over because I was in the middle of the train of thought. How frequently do you start the stream and are you able to solve physics numericals? I stream on YouTube 3 times a week, starting 2 hours ago, 2 hours and 20 minutes ago. I don't know what physics numericals means. If you mean like physics, I can kind of do basic physics problems, but I've forgotten a lot of it. SPQ. That's the simplest way. It's a lot to keep track of. You just have to casually know 90 squared. I guess that's 8100. Okay, that's fair. Yeah, so topology, thank you for the follow. Oh, yeah, topology is another thing I say is pure math. Welcome in. Let's bring up what corrupt put. Hyperbolic cotangent, hey? What the hell is this? Now, I'm going to assume that you tried the obs in giving it to Wolfram. I'm curious, like, what does Wolfram say about this? You haven't? Oh, okay. Because I see this and I don't even know what the hell to think of it. Your other goofy cat? Oh, hey, Walrus. Amelia talks, hey? X minus ln 2 square root. Is there a picture of your other goofy cat, Walrus? The dog will have a friend? True. Cosh x squared. Sounds good, Waffle. Minus x. Because if you think I can just look at this limit and figure it out by hand, you got another thing coming. You might be allergic to hyperbolic cotangent. I feel the same way, Amelia. Oh, what? Wolfram, you're not allowed to just make the problem easier. I know it's scary, but you're here for a reason, Wolfram. Why is one parenthesis bigger than the other? Like, I don't want to do this problem either, so I can't blame Wolfram. What? Freaking Wolfram. No, it just does not like it. Does Desmos at least plot it? Oh my, what? Wolfram. Oh my god. That's how much Wolfram doesn't like this problem. Oh my god. ChatGPT is never been. Ugh. Desmos will do this for me, right? Oh, it does. That looks like 0. Let me tell you. Oh, true. I could have just copied the way tech. Yush ZZ, thank you for the follow. Now, I would be inclined. I don't know by there's no way there's a hyperbolic trig identity that would actually help here. I would think you would have to use series, and there's no way in hell I want to do the work of figuring out what this series would look like. Like I'm thinking numerical for this because I don't. You maybe have a shot in hell of using some kind of identity if there wasn't that X there, but I assume that X is gonna mess up every type of identity. Kappa's been posted. Sounds good, Waffle. Oh, Wolfram doesn't mind it when you try it? Okay. Sprinkle some Taylor, always the answer. Speak you. It's a kind of an interesting looking function. I'm curious what the maximum is. I also don't want to calculate the maximum. What I do to Wolfram, I hurt Wolfram very deeply, apparently. It's not in the talking mood right now. Yeah, no, I have no idea how in the hell you... If you can solve this, I guess, like, analytically is the word. I have no idea how you do it. Don't go traumatizing the software. Oh, yeah, I bet you do, since you do so much work with Desmos. Let's start taking a look at Waffle's cat. Ooh, okay, you posted many, which is even better. This cat looks like it's seen some stuff. Give that 1,000-yard stare. Okay. We got this. Final solutions. Oh, okay. That's why you're curious about the limit, I guess. Silly little guy. Alright, I'll probably try and draw him, like, sitting down. Because I feel like it's just the easiest position to draw a cat in. Orange. A chin TI? Thank you for the follow. What was the prompt for the dog? That was from Talos. The prompt was the Hourglass Dog, I think it's called. I don't know where it's from. How do I draw cats again? It's been a minute since Shep's been in chat to force me to draw cats. Like, okay, the ears though. The ears are not quite the normal cat ears. Welcome in. A chin? I don't know. I'm probably saying that wrong. So my apologies. These are a little like Kirby. They have some pretty glorious ear fluff too. And the eyes. What color are the eyes? Oh, I don't have a color like that. A chin T. Okay, cool. I wasn't that far off then. Oh, well. I feel like blue is the closest color I have, but blue is not even that close. Maybe green. Green's a little bit closer. Oh God. The eyes aren't quite lined up. It's fine. Then draw like maybe a tail wrapped around its legs, his legs. You know, we need some whiskers. Brown eyes? Oh, okay. Yeah, brown is kind of a hard one. Glorious earful, great way to describe it. I don't know. How's that? It's not it's not the worst cat that I've drawn. The back legs are not. Yeah, the back legs a little rough. Otherwise, 10 out of 10. Oh, thank you, Amelia. No worries. I am quite the artist, I know. There's been a bunch of new faces in chat today. I feel like I'm remiss in not shouting out the other math streamers more. So if anyone is maybe new to my stream, A, well, welcome. B, I'm not the only person who streams math. There's a whole list of them right there. And I recommend you just go through the list and hit follow on all of them. They all have different styles. For some, it's like I have math days and I have video game days. A lot of them do a similar thing, or they'll just play games and switch to math if someone asks a question. Yeah, no worries, Amelia. But they all do some math help in some form or another. So yeah, I should be better about shouting them out when I see new people around. This one's guaranteed amazing perfection. Exactly. Guarantee it. If they make a single mistake, then it's just impossible. They won't make a mistake. 3 over in the YouTube chat. Hey, the cubic polynomial with leading coefficient unity, whose roots are 3 units less than the roots of the what the hell? It's a clone the real ones can never eat. Well, exactly. What is F star X? Or the F prime star X? I'm not sure. This one might be above my pay grade. There's a few things in this that I don't know what they mean exactly. Am I looping on this playlist? Oh. Well, actually, no, I'm about to loop, but I haven't quite looped. Okay, cool. It's just f prime x? Okay. Leading coefficient unity, all whose roots are 3 units less than the roots of the... Huh. Okay, so that cubic that's given is groupable. What was that cubic? X cubed minus 3x squared. Minus 4x plus 12. So we could factor in x squared from the first two terms, and factor a -4 from the next two terms, and then, oh, look at that, we have an x minus 3 and x minus 3. Let's factor that out. We get x squared minus 4, and that factors to x plus 2, x minus 2. So the second part of the question, I'm not... Like, how this relates to the original cubic, I need to figure out. Can I just jump up to say thanks for the art? Oh, good. Well, tell your cat he's welcome. 3 units less than the roots of the equation. So if it's 3 units less, is our actual f of x, we take each of these and subtract 3, is my interpretation? So -3 minus 3 is -6, 2 minus 3 is -1, and -2 minus 3 is -5. That's my guess. And we could get the derivative of that with product rule. I might be being corrected here. Let me catch up the chat. 3x squared plus 12x plus 5? Oh, that's the answer that John Reed got. Okay. 1, -1, -5, and 0? Did I make a mistake in how I factored? Oh, I should have flipped the signs. Fair. Yeah, the root is +3 for that first one. Okay. Okay, so it looks like John Reed got A for those options. Shoot, I keep forgetting to do set problem. So, okay, let me fix my work. Because x minus 3 means the root is +3. This means the root is -2. This means the root is +2. So we should actually work off of these and subtract 3. Which means these two are actually, they happen to be fine because we had plus and -2. But 3 minus 3 is 0, so we'd have just an x there. And then we get the derivative of this, which we could do product rule or we could multiply it out. This one's actually not too hard to multiply out. I'd rather do that, I think. Okay, so that's our f of x. So then the f prime x, we just apply the power rule. 3x squared minus 12x plus 5. So yeah, I guess, oh wait, I get a minus 12x. So I guess I'm getting, oh, yeah, I'm getting A. And I mistakenly said that John Reed would also got A, but John Reed got B. Let me verify. Does Wolfram Alpha feeling better? Okay. Let me verify I didn't make a mistake on the multiplication. It's x plus 1, you're saying? Oh, is it? Yeah. Good call. Because that's a root of 0. This should give us a root of -5, but that one should give a root... Well, that should be plus also. Because a negative root means you're doing plus here. I forgot to flip the sign there. Which means that is plus, which means that is plus, which means that is plus. Okay. So yeah, Sri, let me know if that makes sense. Sorry, I didn't do a very good job of explaining it. About your about section, there's no -1 problem. I can't -1 solve. I can't. It comes out to be negative, which means you can't solve any problem, which is not true. It's 4 a.m. for you in India? Oh, geez. Well, I hope you get some sleep. It's no longer late. It's now early for you. I can't solve any problem. The way I meant it is that there's no problem. Like, if you give me a problem, I promise you that I'm able to walk away from it. I'm sure the grammar on that is debatable, but that's my intent anyway. Gotta go have fun? All right. Sounds good, Sri. Thanks for the question. And hey, Shoria. Yeah, I mean, that's just a joke anyway, so I'm sure the people are actually good with grammar. Unlike me, can figure out what it actually means, but that's how I meant it. Solve continuous and differentiability in limits. Yeah, like using a limit to figure out if it's differentiable and continuous. If you have a problem you want to see, I can try and help you with it. JE 2025? What about it? Like, I'm not... I've seen some JE questions before, but I'm not too experienced with them. Generally, ones that I've seen are really hard. Yeah, sure, Neon. It's no problem I can't not solve. Exactly. Oh, am I at 500 subs? And is that the same waffle? Is that a flex for... Oh, whoa! I'm over 500 subs! 502! Holy crap! Dude, I gotta say, like, the sub count on YouTube is growing at a faster rate than my Twitch follower count. My Twitch follower count is still ahead, but, like, this thing without any raids, like I get on Twitch, is, starting to catch up to my follower count, which is kind of interesting. But yeah, thanks for the congrats. And, Sammy, hey to you too. Yes, topology. Can you talk about topology? I don't know anything about topology, unfortunately. Sometimes people around in chat who know about topology might want to talk about it, or my Discord, but you might have better luck asking around in Penn Center's Discord. There's just some more people around. Oh wait, I think it's Pendy? No? What's the command? Or maybe Enigmabot is asleep. Okay, well, YouTube sub count will exceed Twitch follow count. Well, that's extrapolation, you know. Let me get Penn Center's Discord. Yeah, I've never taken a topology class though, so I don't have much to say about it, unfortunately. But Penn Center's Discord is a bit like bigger than mine, and oops, sorry for the double audio. And there might be someone around in there who wants to talk about it, but yeah, I unfortunately don't have much that I can say about it. Evo Paul's P sets definitely. Oh yeah, I mean Khan Academy I've hardly tried because I don't care to watch their videos. I'd rather have it written down like Paul's Notes does. Thanks, Waffle. How to share questions? Type them there in chat or put them in my Discord. Those are the ways to submit quote questions, I guess. I should have kept that open. Get some water. Okay. Just waiting for all to see if Neon or Shoria put their questions in there. I guess in the meantime we'll go back to I don't want to do physics. Maybe we'll look at algebra. Look back what Penn Center signed. 1923. I think I did 19. Check my Discord. Oh, are you the person messaging me directly? Oh, I see. Okay. Ooh. This will be interesting. Oh, sorry, SPQ. Yeah. I looked at it for a second and then switched right back away. We changed the music. So it just looped. The number of points where the function is not differentiable. This one we need to verify in Desmos for sure. But let's write it down on the board and start playing around with it. Why isn't infinity a possible answer here? Surely sine of the absolute value of x. Oh, okay. No? Wait, I gotta think about this. I specifically don't want to graph it until... Like, it's better to do this without a graphing calculator because you don't usually get to use a graphing calculator on tests. But I guess sine of the absolute value of x only affects it at one point. So what's our function? F of x x squared minus 1, absolute value, x squared minus x minus 2, plus sine of the absolute value of x. Okay. So what I want to do is I want to look at this part of the equation and see what non-differential points we get, and look at this part of the equation and see what non-differential points we get. Just as a refresher, a function is not differentiable in two scenarios. If the function has a discontinuity, like a jump discontinuity like that, it's not differentiable there. Or if the function has a corner like that, it's not differentiable there. Sorry about the siren in the background if you can hear it. So you generally have to look out for jumps or, you know, any type of discontinuity in corners. So I don't think we're going to get any discontinuities from here because we don't have any division. But the absolute values tend to create corners, so we need to watch out for those. Hey, Alex Lanza. How's it going? Oh wait, SPQ has a double equal sign. So actually, maybe SPQ is asking if algebra is equal to Pog. It's been a minute, Alex. I remember your name, but I don't think I've seen you around in a minute. I hope that you've been well. Okay, so looking at the part on the left, I want to factor that part inside the absolute value and just see what it looks like. It's going to be x minus 2 times x plus 1. And actually, we should factor the x squared minus 1. Sorry about the sneeze. That's interesting. We have an x plus 1 inside and outside of the absolute value. Okay, so I want to graph this ignoring the absolute value and then fix it afterward to figure out how the absolute value affects this. So this is a quartic function. -1 is a repeated root, so it's going to bounce there and cross over the other roots. So we have -1, +1, +2. And it's facing up because the leading coefficient is positive. So it bounces, it crosses, something like that. Sorry to interrupt you. What do you think of teaching method used in primary and secondary schools? Thanks, Waffle, for the bless you. It's no interruption. I won't be able to like talk about it at length. That's kind of like a very big question. It can always be better, but I'm not that well versed in education. I would say someone who I bet would love to talk about this is e to the 2i pi, or Zach, because this is actually something he's doing his PhD on, like involving that. I didn't have a particular problem when I was, or I don't have a particular problem with how I was taught, I guess. But oh, and OB2. Sorry, I forgot about that. But just because it worked for me doesn't mean it works for everyone. And I think like it's really easy to poke holes in how and point out the bad parts of how education is, but saying what it should be is way harder. Achinti, don't know what differentiable exactly means. It means that you can find a tangent line to the function to try and like put it in simple terms. Like this part of the function has one unique tangent line that you like, there's no debate where the tangent line is like at that point. But if you have a function with a corner, like there's a bunch of tangent lines you could draw. You could draw that line, you could draw that line, draw that line. Like it's not possible to agree on what your tangent line should be. And the other scenario where it's not differentiable is with the jump. Or like any type of discontinuity you want. Like how do you draw the tangent line right at that point? It's just in two different spots. Like I don't think drawing a tangent line like that is going to particularly mean much. Like the derivative is your rate of change, and it's really hard to describe. Like it's like an instantaneous change in your rate that doesn't really happen physically. You have to like, even if it's really quick, you still have to gradually slow down or speed up. And this is like almost like a make-believe scenario where you're somehow speeding up or slowing down instantly. Yeah, exactly. The limit has to exist, which means it's continuous. That's a part of being differentiable. The other part is being smooth without a corner. So you can be continuous and not differentiable if you're like that, but you do definitely have to be continuous. Okay, sorry about the little side conversation there, Neon. So back to this. This is what the quartic would look like if there were no absolute values. But we'd have to figure out what the absolute value, like how does this absolute value affect the graph of this quartic? We're going to split it up into sections, and well, it's always positive already, except between 1 and 2. All we really have to figure out is between x equals 1 and x equals 2, if this little negative part needs to get flipped up top. That's the only question. So let's just plug in 3 over 2, halfway between x equals 1 and x equals 2. Five over 2 times 1/2, because 3 over 2 plus 1 is 5 over 2. 3 over 2 minus 1 is 1/2 times the absolute value. 3 over 2 minus 2 is -1/2. 3 over 2 plus 1 is 5 over 2. Oh, so here, this would be a negative number inside here, but the absolute value is going to flip the sign. So if the absolute value bars weren't here, we would get a negative number. But because they are here, this ends up turning positive. So I think the only... Ooh, could this actually change in somewhere else? I think the only thing that's absolute value changes is this part. We might want to check between all the other roots, to be honest. But we definitely know this part between 1 and 2 is positive, so it just gets flipped up. Just there? Okay. Put some of the basics of linear algebra. Trying to get into game dev. Oh, cool. Yeah, I know Zach's recommended 3 blue, 1 brown. I think Enigma likes Jeff Suzuki. Let me try and quickly convince myself that it doesn't, because I'm worried about like if there's a double negative, if something could get flipped. So if we plugged in x equals 3, positive, 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 positive. Okay, so the right side is fine. That's second to right part is fine. The middle part, if we plug in x equals 0, positive, negative, negative, positive. Yeah, x equals 0 is a problem. Because we get 1, negative 1, absolute value, negative 2, 1. Negative 1 times the absolute value of negative 2. So actually, funny enough, this absolute value causes something that was positive to flip to be negative. And I don't know what that means for the differentiability. I think it is differentiable at this point now, because the middle part just got flipped. I don't know about at that point, though. Well, let's check x equals negative 2. Negative, 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 negative. So the left part is still positive. So everybody answer so late. Oh no, your connection isn't good. It's all right, Waffle. I don't know of a good like linear algebra resource offhand. So I don't know too much about it. I don't have a great suggestion for you. Alex, the quick version of my answer is I acknowledge there's a lot of problems with like the current education system, but I think that everyone's able to point out problems and no one's able to point out solutions, or at least solutions that people can actually agree to, I guess. Like, I don't have like a good problem with my education personally, but that doesn't mean that it doesn't work. That doesn't mean that it works for everyone. Yeah, I don't have a particularly good answer. There are 2 people who might be able to speak more intelligently. And sorry, Neon, I'll get to the sign absolute value of x part. I'm still wondering about the left part of that graph if it's differentiable there. I don't think it will be if I drew it better. If you want to talk more about it, the 2 people who can speak about it more intelligently are Zach, aka Toy Pi, and N-Simplex Pachinko, aka Obi. So I'd recommend you try out their streams if you want to like really like talk about it, because they have studied it and think about it a lot. It's not something that I know that much about, to be honest. It might be, yeah, Fenvox, you're probably right. Because if we have a bounce, something vaguely parabola-ish, and then we flip, and then we vertically flip this right side, it looks almost like a cubic. So I think it's going to be differentiable at -1. It's definitely not differentiable there, but we only get one not differentiable part from here. I think that part is going to be differentiable, even though my drawing isn't perfect. Yeah, so your other question is about sign of the absolute value of x. So let's do the same exercise. We just sign absolute value of x in blue. So sine of x looks like that. So for all the positive values of x, nothing changes. Yeah. Like, I think the entire right side of this sine curve is going to be the exact same. But the thing is, when you plug a negative number in, that's going to flip. I think this thing is going to get mirrored. Like, we're going to take this positive part and, like, flip it over and mirror it over on the left side. Because the negative input of x is going to get turned into a positive. So, like, at negative pi over 2, it's going to be whatever the value of positive pi over 2 is, which is the peak right there. So you almost get like a McDonald's M for this first part of the sine wave. So oh, just saying, hey, listen for fun? No worries. Yeah, you can type it out there in chat, or you can put it in my Discord. Okay, and so we get one non-differentiable piece at x equals 0 from the sine of absolute value of x part. We get non-differentiable piece from the quartic at x equals 1. So those are two distinct points. Like if they both happened to occur at like x equals 1, we still only get one. But I think where we have a non-differentiable point, if you add these two together, it still won't be differentiable at x equals 0, and it won't be differentiable at x equals 1. So I think my answer here is 2. Let's plug it into Desmos and make sure, though. And let me know if you have any questions about that, Neon. So far. See, I guess I'm saying C. It's at 0 and 2. Oh, I misspoke. You're right. I'm sorry. You're right. It's the non-differentiable pieces I'm saying are 0 and 2. I just accidentally said 1. Thank you for that correction. Alright, so let's just for the quartic piece. Yeah, that looks differentiable there. It's smooth. And that's the only corner that you get from the quartic. Let's actually do these separately and then do the addition after. Oh yeah, McDonald's M. Everything else is the same. And now if we add these, oh, it's pretty subtle on the final graph, but that's not differentiable there. There's still a slight corner. And then there's a more obvious corner there. So yeah, I'm pretty confident that 2 is our answer. That's because in Italy there are many problems. You're Italian? Oh yeah, I bet both of them would love to watch them. Or, sorry, I bet both of those people would love to talk about like how it is in Italy. You dare say Penn Center would be interested too? Okay. Shout out Penn Center. You'd also be down to yeah, people want to talk about it. Oh hey, okay, yeah, I guess a lot of people are interested in it. I know that Dan wanted to put together like a whole discussion about like what a math curriculum should be. The trick to differentiability at -1 is that d by dx at -1 is 0. Oh yeah, SPQ, that's a nice like test. And hey Suna, you can do differentiability tomorrow. I forgot what type of math you were. I've seen you working on, but yeah, it's really just like you can work it out kind of like algebraically and like drawing rough sketches, but the best way is just like grab it like this and look for discontinuities or corners. So only based on the philosophical nature of education. Yeah. Sounds good, Neon. Thank you very much for the question, and good luck with the rest of your work. I know what the command for Dan is, but I figured Dan's on hiatus anyway. I assume he wouldn't be organizing that discussion in the near future. Wish you could graph it at the exam. Yeah, it's definitely a lot easier when you have Desmos. I put some rough sketches on the board, but especially with corners, you can get some like, it can be like, is that a corner or is it actually smooth? Hey, Nightmare. Nothing much with me. What's up with you? Welcome in. Okay, is there anyone who maybe asked a question that I missed in the meantime? Let me scroll up in chat. Oh, SBQ's curriculum. Category theory, commutative algebra, point set topology in elementary school, and machine learning and other CS stuff afterwards. Oh god. I don't want to go to SBQ school. Let's do some integration. I guess like if someone has a homework problem about integration, I'll do it. But kind of like the emphasis of my stream is, I want to do problems that people actually need help with. And if someone asks an integral and need help with it, I'll do it. But if I'm doing math for fun, then I'll usually do abstract algebra or physics. Yeah, I've definitely seen that problem before, and I don't think that's your homework problem. Somebody in Pro put something in my Discord like 13 minutes ago. Are they here? Do we know what I don't know? Just enjoy watching math. Oh, well, I appreciate it, Amelia. There's quite a few videos of that integral, as far as I know, Nightmare. I've been loosely following the other math classes on Twitch, which, actually, what's my command? I should be shouting that out, too, when there's new people. Oh, no. Did my command not get saved? Didn't get saved. I'm loosely following the classes that are happening, but participating in them super actively and getting on the calls, it's a little bit too much of a time commitment for me. Hey, Gold Lover. Why isn't part containing x equals 0 just a reflection across the x-axis? It is. If you're talking about that quartic, hey, study, Luca, JE. If you have a specific question, I can try and do it, but I don't know very much about how JE works. So yeah, Gold Lover, basically my process was I ignored the absolute value signs and I graphed the quartic as if it was normal. And then I split it up based on the roots, and I found whether each section, like x equals 1, x equals 2. Basically, if the section to the left of -1, between -1 and 1, between 1 and 2, and to the right of 2, whether those get flipped or not because of the absolute value bars. So I plugged in test points for each of them. And so I found that the part between -1 and 1 gets flipped, as you say. And the part between 1 and 2 gets flipped. So you end up with this graph. I guess I can show them both at the same time. What's up, critical? Okay. System integration homework right after waking up. Oh, okay. Good luck with that nightmare. I'm probably gonna have to wrap the stream up after Critical's question. My voice is definitely like not great. Doing inverse matrix. Can you send me what the algorithm is? There's a few ways to get inverses, I think. There's like what the screenshot of an example problem or something. Hey, Proof Viraj. You can just type it once. I see you. What's the question? What are you trying to integrate? Okay, I remember this. I think. Okay, that's our question. So the algorithm that they're saying is you take this and you make it an augmented matrix. But instead of one column, you actually have the identity matrix here. Your operations still work the exact same way, though. The goal here is we start with matrix identity here, and we want to do anything it takes to get the identity over here. In the process, that'll change how the right side looks, and the right side is going to end up being A inverse. So good news, we already have the 1 in the upper left corner. We want ones all in the diagonal, and we want zeros everywhere else. So let's get rid of the numbers here and here first off. So I'm going to take row 2 and subtract 4 times row 1. I'm going to take row 3 and add 2 times row 1. -7 plus 8 is 1. Oh, convenient. 3 minus 4 is -1. 0. 6 minus 4 is 2. -4 plus 2 is a -2. Okay, and then we have 0 minus 4 is a -4. 1 minus 0 is 1. 0 minus 0 is 0. 0 plus 2 is 2. 0 plus 0 is 0. 1 plus 0 is 1. Okay. Let's get a 0 here now, and actually a 0 up on top. So I'm going to take row 1, add 2 times row 2. And take row 3 and subtract 2 times row 2. 1 plus 0 is 0. -2 plus 2 is 0. 1 minus 2 is -1. That stays the same. Zero plus 0 is 0. 2 minus 2 is 0. Minus 2 plus 2 is 0. Oh, interesting. Is this not invertible? It might not be invertible. Okay. See, as soon as we get that row of zeros, I think we know it's not invertible. That's basically the process that you would follow. No, if you get a row of zeros like that, it is not invertible. It's on my Discord, Neon. That would be the rule if it's a 2x2. This is a 3x3, so if the determinant of 3x3 is 0, then it's not invertible, which I assume it will be 0 because of what we got. But AD minus BC only works for 2x2. For bigger matrices, the determinant is harder. Yeah, so if you dig with the triple gain determinant, you'd find that it's 0 for the 3x3. Oh my god. Does that make sense? Critical? Looking at the next question. No worries. Something with E, I can tell you that much. Do you have the solution handy? Like, I can maybe like explain the solution to you. I don't know how to solve this blind though. That's not an easy limit. It's a famous question for JEE. Oh. About all binomial properties, you can sub-zero, you get 1. Your guess is e to the x. I mean, it's got to be something with e, I'm sure. You just get these problems in the exam hall. It's not unreasonable. Something a limit. Yeah, I can Google it. I can't solve this though. I don't like watching videos on stream. Let's see if that's enough to bring it up. 0.03% solved it? Oh my god. Okay, doing it with a log seems reasonable. Oh. It's one of those where you have to notice that it's equivalent to the Riemann sum definition of a limit. No. I can't do this. Thanks for the follow, Gold Lover. So yeah, I'm sorry, Yash, I just can't do this. I also am gonna wrap the stream up, I think, because if the guest doesn't work out, giving up is an efficient approach. Yeah, what's the answer? If it's a quick one, I'll look at it, Yash, but I can't stream for much longer. This is f of x. Terrible. Get strawberry cheesecake. Probably. There's been quite a few questions about JE today. So yeah, sure. Are you putting the poster, or are you just gonna are you good for now? You can still post in Discord if you want, and me or someone might get back to you off stream, but I'm getting tired. Meantime, I'm looking for math streams right now. Okay, I'm gonna call. I don't see anything else happening, so I'm gonna cut the YouTube stream off here, I think. So yeah, for anyone who's here on YouTube, I appreciate you. Back on YouTube on Saturday, first for the reading group, and then we'll do some math help after. So yeah, YouTube people, thank you, and see you later.